Symmetry is all around us, from the beauty of nature to the pattern in architecture and art. It's an inherent concept that creates harmony and balance. In this video, we will deep dive into three fundamental types of symmetry: reflections, rotations, and translations. First up, we have reflection symmetry, also known as mirror symmetry. It occurs when an object or a shape can be perfectly divided into two identical halves, like a reflection in a mirror. Now let's deep dive into some example and equation to understand reflection symmetry better. Consider this equation, y equal to x square. It's a parabola that opens upward and its vertex is at origin. Now let's find the line of symmetry of this parabola. To do that, we need to find the axis of symmetry, which is the vertical line that passes through the vertex of the parabola. The equation of the axis of symmetry is x equal to 0, which is the line y-axis. Let's try another example. Consider a square. The square exhibits reflection symmetry. This means that it can be divided into two identical halves along a line called line of reflection, in such a way that each half is a mirror image of each other. In the case of square, these lines passing through the center from one side to the opposite side are the lines of reflection. Next, we have rotational symmetry, which is all about spinning and turning objects. Imagine a shape that remains unchanged even after rotating it by a certain angle. That's rotational symmetry. Now let's dive into some math examples and equations to understand rotational symmetry better. Consider a square. It's a perfect example of rotational symmetry. We can rotate it by any angle and it still looks the same. Let's try another example. Consider a regular hexagon. It has 6 sides of equal length and 6 angles of equal measure. Let's rotate the hexagon by 60 degrees and see what happens. What do you observe? The hexagon looks the same after the rotation. This is an example of rotational symmetry. Consider the equation y equal to x square. As you know, it represents a parabola. Now let's rotate the graph by 180 degrees about y-axis. The graph still has the same shape and symmetry after the rotation. Last but not least, we have translation symmetry, which involves shifting or moving an object without changing its shape or orientation. Imagine a shape or pattern that repeats itself infinitely in a particular direction. That's translation symmetry in action. Now let's deep dive into some mathematical examples to understand translation symmetry better. Consider the equation y equal to 2x plus 1. It represents a straight line with a slope of 2 and a y-intercept of 1. We'll shift the graph horizontal by a fixed amount and observe what happens. What do you notice? The graph retains its shape, orientation and slope, but it has moved parallel to itself. Now that we have explored each type of symmetry, let's summarize what we have learned. Reflection symmetry is like a mirror image. Rotational symmetry involves spinning or turning. And translation symmetry allows objects to be shifted while keeping their original shape. Thanks for watching. See you in the next one.